we will solve an exercise question 3.11 from chapter 3 of NCERT chemistry text part 1. The conductivity of 0.00241 molarity acetic acid is 7.896 into 10 raised to minus 5 Siemens per centimeter. Calculate its molar conductivity if lambda m naught of acetic acid is 390.5 Siemens centimeter square per mole. What is its dissociation constant? The formula to calculate dissociation constant is K is equal to C alpha square upon 1 minus alpha. C is concentration of the solution and the value is given in the numerical as 0.00241 m, where m represents molarity and molarity means mole per liter. The value of kappa, that is conductivity of the solution, is given as 7.896 into 10 raised to minus 5 Siemens per centimeter. Lambda m naught is also given, but the value of alpha we need to find, that is degree of dissociation. The formula to calculate alpha is lambda m upon lambda m naught. Lambda m value is not given, which we need to find. To find lambda m, the formula is kappa upon C. Kappa's value we have and the concentration of acetic acid is also given. After simplifying this step, we get lambda m is equal to 7.896 into 10 raised to minus 2 upon 0.00241 Siemens centimeter square per mole. The steps of calculations are shown here. Now we solve the sum using log. So we write log of lambda m is equal to log of 7.896. Here it is multiplication, therefore plus log of 10 raised to minus 2. Here it is division. So we write minus log of 0.00241. Next is to convert these into simple log. Here it is already in simple log form, but here we need to shift the decimal to 3 digits towards the right, and therefore we write into 10 raised to minus 3. Log of 10 raised to minus 2, we know it is minus 2. Similarly, 10 raised to minus 3, log is minus 3. We find the log of 7.896 and log of 2.41 using the log table. How to find it is shown in these two boxes. After solving all these steps, we get log of lambda m is equal to 1.5154. To get lambda m, we have to find antilog of 1.5154. Here the characteristic is 1, so in the answer we write into 10 raised to 1. In the antilog table, we will see 0.51 under 5. That comes out to be 3273. And mean difference 4. Mean difference 4, the value is 3. After adding, we get 3276. And in the answer, after one digit, we place the decimal. So we get the lambda m value as 3.276 into 10 raised to 1 Siemens centimeter square per mole, or 32.76 Siemens centimeter square per mole. Using the lambda m value, we calculate alpha, that is degree of dissociation, and the value of lambda m naught is already given in the numerical. So we substitute the values of lambda m and lambda m naught in the formula. Now again we solve using log. So we write log of alpha is equal to log of 32.76. Here it is division, so minus log 390.5. We convert them into simple log. Here we shift one decimal to the left. Here we shift two decimals to the left. So here we write one decimal is shifted, so we write 10 raised to 1. And here we write 10 raised to 2. After solving these steps, finding the log and doing all the calculations, we get log of alpha is equal to minus 1.0763. Now we write alpha is equal to antilog of minus 1.0763. Since this is a negative number, to convert the mantissa positive, we know that we have to add minus 1 to the characteristic and add plus 1 to the mantissa. We get minus 2.9237. Now we find the antilog of this number using the antilog table. We see 0.92 under 3, that is 8375, and the mean difference we have to see it under 7, the value is 14. After adding, we get 8389, so we write here, and after one digit we place the decimal. Characteristic is minus 2, so we write into 10 raised to minus 2, or we can write it as alpha is equal to 0.0839. Now we find the value for k using this formula. We have the value of c already in the numerical, and alpha we have just now found. We substitute these values and then we solve it using log, and therefore we write log of k is equal to log of 0.00241. Here it is multiplication, so we write plus, and here it is square, so we write 2 log of 0.0839, and here it is division, so we write minus log of 0.9161. To make them into simple log, we shift in this case 3 decimals to the right, here 2 decimals, and in this case 1 decimal to the right. So respectively we write 10 raised to minus 3, 10 raised to minus 2, 10 raised to minus 1. Log of 10 raised to minus 3 is minus 3. Similarly, log of 10 raised to minus 2 is minus 2, and log of 10 raised to minus 1 is minus 1. Using log table, we find log of 2.41, log of 8.39, log of 9.161. After all the calculations, we get log of k is equal to minus 4.7323. Then we write k is equal to antilog of this negative number. To make the mantissa positive, we have to add minus 1 to the characteristic and plus 1 to the mantissa. And finally, after all those steps, we get minus 5.2677. The characteristic is minus 5. So in the answer we write into 10 raised to minus 5. And for 0.2677, we find the value using the antilog table. 0.26 under 7 is 1849, and the mean difference 7, the value is 3. After adding, we get 1852, and after one digit we place the decimal in the answer. So the value of k is equal to 1.852 into 10 raised to minus 5 mole per liter.